we are given two graphs here, and you can see that they are the same graphic. The difference is our horizontal axis. So in the top one, we use the years, and it shows in the y-intercept. The bottom we use, so 0 would be 1970, 45 would be 2015. So you can see that's the difference. So the slope is the same, so let's interpret the slope. The slope is 0.0163 over 1. The numerator represents degrees Celsius, and the 1 is years since 1970. So degrees Celsius increases 0.0163 for every year since 1970. And I say increases, right? It increases because the slope is positive and it goes up. Use the trend line from the first graph to predict global temperature in 2016. So we would use X is 46. I lied. In the first one, we would use X is 2016 because they're using the years. My bad. So Y equals 0.0163 times 2016 minus 18.234. So we multiply first, then subtract, and we get a value of 14.6268 degrees Celsius. Okay, keep that in mind because we're going to compare this in a second to something else. Number 3, use the second trend line. Well, down here, we're going to use X is 46. So when I plug that in, I've got Y equals 0.0163 times 46 plus 13.964. Now we multiply first, then we add the 13, and I end up with 14.7138 degrees Celsius. So you can see 14.6268, 14.7138, they're off by a little. Not quite a full tenth of a degree, but they are off a little bit. So even though they're both correct mathematically, it does result in a slightly different prediction because of the way that things are written. Okay, there's nothing wrong with that. Number 4, find and interpret the linear correlation coefficient. Again, you will see they are the same. So R squared is 0.8567. The linear correlation coefficient says to square root both sides. Slope is positive, so this is going to be a positive, and we end up with 0.9256. Strong, positive, linear correlation between degrees Celsius and years since 1970. Strong because it's the 0.9, right? And positive because our slope is positive. Linear correlation. Good. All right, now looking at these two graphs, discuss how these graphics are reflected in the graph of 70 to 2014 on the previous page. Now, 1970 to 2014 is like in this section, right? So 1970 here, it's this one. But you can see that there is a large increase. So here we're showing the increase. And so they do correlate, they do make sense because they are both showing an increase. Now, this graph here up top, it just shows a straight up increase. Whereas the one down here, you can see there are some up and downs with different pieces. So you can also see here that the dots up and down do show a variation. And what is the scope of the model and how is it important? Well, in the top one, our scope is from 1000 to 2000. And down here, we're from 1880 to 2000. So how is it important? Well, they show a way larger group. So, I mean, here you're adding, almost 900 extra years of data, which shows that there was almost no change. I mean, a little variation here and there, but that the variation really doesn't kick in till, here, maybe 1880. So it's very interesting to kind of see how these are related, the information they give you, and so on and so forth. So the different scopes allow for different information, allows for more information. You can see in 1940 there was a little bit of a spike in a temperature while the CO2 stayed down. So that would be something that if people are trying to say no, CO2 is not causing temperature, right? I mean, you can argue all kinds of crap based off this. It's all speculation, right? But different graphs show different things, and different scopes give different information.